Alright, 3.2.26. So let's have a look at this one. Suppose you just received a shipment of 12 televisions. Okay, 12 TVs. 3 of the TVs are defective. Alright, so if 3 are defective, that means 9 are not defective, right? (12 minus 3 equals 9). Okay. If 2 televisions are randomly selected, compute the probability that both televisions work. What's the probability at least one of the 2 televisions does not work? Alright. So the key thought to this one is thinking about with replacement versus without replacement. Okay, so in this case they don't use the word replacement, but the situation comes up. So if you take the first TV and it's not whatever it is. Okay, so let's do this first. So the first TV comes up. What's the probability that both televisions work, right? So the first TV has got to be not defective. What's the probability it's not defective? Well, 9 of the 12 are not defective. So the first TV, 9 out of 12, it's not defective. Okay? Times, what's the probability the second TV is not defective? Well, in this case, you've taken the first TV out, right? It's not there anymore. It's not part of the sample anymore, not part of the group he's going to choose from. That makes this without replacement. So since the first TV's already been chosen, there's only 11 TVs left, right? And how many of them are not defective? Well, the first one wasn't defective, so we've got one less not defective TV also, so only 8 left are not defective. Alright, you can multiply this out on your calculator or whatever. You can do it however you want to work that out. If you're going to do it by working here, you can take a 3 out of here and a 3 out of here, leaves me 3/4. And then the 4 and the 8, so take the 4 goes down to 1, the 8 goes down to 2, and that leaves me with 6/11. And it says round to 3 decimal places, so they want the decimal answer rounded to 3. That is 0.545. Part B, the probability that at least one of the 2 televisions does not work. Alright. At least one in pretty much every problem is the main situation where you think you want to do the complement. The complement of at least one is none. Okay, so let's think about that a minute. If you say at least one, right, no matter how many you're going to draw, like in this case you're only going to draw 2, right? So this would mean either 1 is defective or 2 is defective. Well, the only options are 0, 1, or 2, right? So this says the probability that either 1 or 2 is defective. The complement of that then would just be 0 because that's all that's left. In a case if there were 8 options and you said at least one would mean 1, 2, 3, 4, 5, 6, 7, or 8, right? Well, the complement of that, everything from 1 to 8, would be 0 because that's all that's left. The complement is always everything else, right? In any case, the probability of the complement is always 1 minus the probability of the original, which is 5/11, which, again, they asked for the decimal, so that's 0.455.